Okay, so today I will be reviewing the week one of my ML Zero to Hero Mastery. So, as part of that, actually, I am following two courses. One is a course and one is a book, actually. So, this is Complete Machine Learning and Data Science Bootcamp 2021. This is by Daniel Borke. I think you can find him on YouTube as well. You can just search him. I will post these links in the description. Whereas this is one another book. I think this is very highly recommended book for starting machine learning to learn. So I am following those two books. So the starting few days, right, this 7 days, I have been posting on Medium regarding what I am learning based on that. So if you go here, right, so these are the different notes that for the first week I have posted, and I'm putting this in the Twitter as well. So what happened the first 7 days, right? It was mostly theory. So it was means I can put them in the blog post. But after that, what happened? Coding and all this started. So it's mostly the IPython notebook that I am using. So that I will link that as well. So this mostly is the way I thought I will do this review for the one week is I will pick the set of questions. So it will be in the form of a question answer form of what I have learned, or after the end of 1 week what I should know. Yeah. So let's start it. So I think the first question comes, that is, what is machine learning? So after going through these boot camps as well as this book, right? So what I understood is machine learning is programming the computer so that it can learn from the data. Okay, so that part is very important. It's learning from the data to find patterns in the data. The data aspect is very important. Now the next question that comes is we have different machine learning. AI is, sorry for this image, this should not have been here. There should be supposed to be a different image, but okay. So what is the difference between machine learning, AI, deep learning and data science? I think you would have learned all this words a lot, right? And really for me also it was difficult to differentiate between what them, and these two uh, resources, right, they really tackle these questions in the beginning. So mostly so I let me start with AI. So what they mean by AI is something which can think like a human or do like a human, mostly that. Okay, so they think of AI as a branch. Okay, something like a physics or chemistry. AI itself is a branch, that is a huge branch. Okay, that comes under computer science branch. Now in AI, it's mostly like, okay, how a human, means a computer behaving like a human. That's what is there in AI. And you can think of examples like, say, Dijkstra algorithm, the to find the shortest path between two routes, right? The way we will go through is the same. Okay, we will look through, okay, from here to, we have to reach some other place, from India to England. Okay, what all places I need to go through, which track will be the smallest where I should go through. So these are the Dijkstra algorithm, different the shortest path finding algorithm that can help. Or apart from that, something like playing chess or a Go. Okay, for humans it might be their problem, but to make that thing understand for the computers, no, it's a challenge. So it's always like, okay, how much we can train that computer to behave like humans. So that is AI. Now how will define the machine learning? So machine learning comes inside artificial intelligence. Okay, so machine learning is always about data, to find patterns in the data so that it can predict the future. Now you can think, means actually that image was supposed to be here, but wait, I will find that over Google if I can see. Okay, so this is the image with I'm looking for a better image. Yeah, this you can see. See, so this is the artificial intelligence. Now machine learning comes in that. Now I had the question of what can be here. So mostly what I think, like say dynamic programming, okay, if you see the way we solve those questions, okay, 01 abstract problem, or there are many other things, the Dijkstra algorithms and everything, they will come in this part because there's no such pattern which we are going through in a computational way. Means first row will fill and the second row and like that will traverse. So it's not like finding patterns in the data. But machine learning is all about finding patterns in the data. Patterns, what I mean by that, say if you show an image of a car, right, it should be able to understand, okay, what I mean by car. It should have four wheels, okay, the body of that, the gates of that, okay. If you show a tree, the trunk, the leaves, the roots and everything, okay. So it's about all about finding patterns in those data. That's what we are concerned in machine learning, okay. Or one good example will be to figure out if a mail is a mail, okay, so email that is a spam or a not spam, okay. So what all uh, characters are coming in a spam email and what are not coming in a non-spam email. So something say, uh, congratulations to you, you have won this and that. That's how the spam emails come, okay. So now when the machine learning learns, okay, if the words congratulations to you, you have won this many price of rupees, you train it, okay, it should be. Now what that person who was creating spam, right, he came to know, okay, I think he has trained the model to do like this, okay, let me change those words. So congratulations, he will introduce a letter in between that. Now machine learning will not be able to figure out, okay, that is a spam or not. So that's how it tries to find those pattern. It tries to learn those, that okay, those words, what words are expected in a spam email, so that it can categorize that as a spam or not, okay. So that mostly machine learning. Deep learning come inside machine learning. There is not that much of an explanation here of what um, it is, but it's also a type of algorithm which helps us to tackle very difficult questions, okay. It's very computationally heavy and neural nets are using here, so these and that. And data science, we learn this a lot, right? So mostly data science is something which is part of everything. So in data science we come across collecting data, cleaning the data, then we feed it to a machine learning algorithm which tries to find the patterns to predict something, okay, deploying that. So you can say, means it's everything, means it's part of everything. It's not completely AI because there are many aspects related to the data, cleaning of the data and everything. So those aspects don't come in AI. So it's kind of like this, okay. So that was the difference. Now why do we need machine learning? So actually, it's not that it has come right now. It has been there for many long time. And previously, if you remember, people used to do it in Excel sheets, okay. They will try to find patterns, create graphs and everything. Then data grew a bit more, then we came up with relational databases and everything. It grew a bit more, then we came up with the big data, right? But the problem was, big data, you can understand, it's in GBs and TBs of data, and for a human being to analyze those amount of data to predict the future, it was very difficult. We needed something like a machine which can really run from morning to evening, which can process all those data and give us some output in a much faster way, in a much more efficient way, okay. That's where we needed machine learning mostly. It's it's the main, the heart of the machine learning is the data part. So you should remember, every time when we talk about data, right, it's the machine learning. Now, yeah, okay, so some tasks are easy for us but difficult for the computers. So you can think of like, yeah, playing chess only, or figuring out there is a cat in an image or a car in an image. For a human being, right, from the when we were small and when we grew up, right, we have those understandings in our head how to figure out what is a cat, what are the certain criteria, the four legs, the eyes, the ears, or something you can figure out. But for a machine learning, for a computer to make him understand, which understands only zero and one, how to make them understand, okay, that is a cat, it's a difficult task. So machine learning is the one that helps the computer to understand those images, to understand those complex problems which looks very easy for us but it's very difficult for the computer. Okay, now comes what's the difference between a normal and a machine learning algorithm. So Actually, in this, right, Daniel Walker gives a very good example. So, what it is normal algorithm, you can think of it. So, you're trying to cook, say, chicken tandoori, okay, whatever the favorite recipe you like. So, you have the ingredients, okay, you have the steps to do that, okay. So, in a normal algorithm, these two you will be having the output that's expected out of you is to prepare the chicken tandoori, okay. So what you will do, you will take those ingredients, try to follow all those steps, okay, heat it, put masala, oil and everything, cook it for this much time and you get the result, okay. So it's easy peasy. Now for the machine learning algorithm, the question is, you have the ingredients and you have the output, but you don't have those steps, okay. So that's where the catch comes. So what machine learning does is it tries out different things, okay. It keeps on trying, it fails, it learns from them, it succeeds some amount of time, it learns from them, and at the end of the day we try to predict those steps which can help us to create good chicken tandoori. So that's what machine learning is. Now how ML are segregated based on data. So this thing has got good amount of importance. I think mostly in this book you will see the definition. So one is the supervised learning. So now it's mostly how we are feeding the data to our model, okay. So when we say regressions, right, so what it means, it's a label data, everything is labeled. Say when we are discussing, okay, this is about a car, okay, so these are the different car companies, this is the color, the odometer, the how many doors are there and what is the price of them. Now what they do is, this is all labeled, okay. So thing you can this thing you can understand as if it's an input and this is the output. Now say the next field what they give is, okay, I give you a car, I give you the color of it, I give you the odometer and the door, what is the expected price of that, okay. How can you predict the price of that? So this is what is known as supervised learning, okay. And where mostly you are trying to predict this sort of numbers, right, where you plot the graph and try to predict this number. So this comes in regression. Categorical is mostly those spam or non-spam where you're trying to categorize, okay. So there also you will have in the form of say list. Here you will have the words the mail, and here it will be spam or not, here mail spam or not. So based on the last one you will get a mail. Now you have to figure out it's a spam or not spam, okay. Now the unsupervised learning, so these was mostly around label data. Here you don't have any labels, so you can see it means just this. You can think of, say you have a blog post and these many customers are coming, you give the clustering algorithm and say, okay, just categorize it. So this is how it categorizes. One can be which those people who are interested in sports, those people who are interested in say programming. So you don't provide it any label, okay. It only tries to figure out, okay, what are the different labels and how I can segregate it. One another comes is anomaly detection, where in our data you can have some weird amount of data, okay. So data is expected to be in the form of this, something is outside there, okay. So it helps to predict that. So that's what comes in unsupervised learning. Now dimensionality reduction, so you have different amount of these columns, right, okay, so many columns, but some of them will not be important. Say here when you are talking about the you can take an example, say okay, about a car, okay. So here we are saying that, okay, if it's a Toyota and it's a white, its price is more. Honda and red, its price is more, okay. So we're trying to form a segregate, okay. If we combine these two columns, say make and color, if we combine these two columns, and then can we predict it, so that just to reduce the number of columns. Because if you have to understand, if there are good number of columns, right, if there are 100 columns, that algorithm will take that much amount of time, that much amount of resource. And if these two doesn't make sense to segregate them rather than to combine them and to form a single column, and if we are getting, okay, we are able to predict good amount of this, that's very helpful. So that's what you can do in dimensional reduction. In association rule learning, this is mostly you can think of when you go to a mall or a where you buy different sort of, where you have different types of products there, okay. So if you are a that conscious guy, you will buy a oat, you will buy honey, dry fruits and everything. So what it does, that it tries to see, okay, that person buys a oat first, then he buys the honey, then he's buying a dry fruit. I'm just taking an example. So what that mall person will do, he'll put the uh, oats section here, next there will be honey section, next will be dry fruit section. So it's much more helpful for the customer, and he doesn't need to search for those things because our algorithm knows, okay, if the people are buying oats and honey, after that they are buying dry fruits, okay, so let's keep it nearby. So these two were mostly label data, non-label data. We deal with them. This is the semi-supervised learning. So there was, I think, a good example in here that was given. This mostly you can think of as a Google Photos. So when you upload say 10 photos, right, your image is there in those 10 photos. First, what that Google Photo will do, it's try to segregate it. Think of something like that. Okay, it will try to segregate it. Now you will say, okay, it has predicted in that your photo somewhat you look like this. Okay, it still doesn't know, just it has segregated. It doesn't have the understanding of what it is. Then you say, okay, these are the data points which represent my photo, means your image. Now what Google will say, okay, I predicted this, I categorize these amount of images as some one person. Now you give that name as Abhishek. So now in all the images, what it will do, it will tag that as an image. So usually in Facebook, you would have seen, right, when you upload photos, it tries to tag different people. So that's what happens. It tries to segregate first. Okay, there are 5 images, say 5 people are there in a photo. First, the job of the algorithm is to predict, okay, there are 5 photos. Now who are they? That is the next step. That's where you help them. So that is what comes in semi-supervised. So first you gave an image which was not like labeled, then you gave a label, say this person is Abhishek, this person is this. Algorithm tries to learn from them. And then comes the reinforcement learning. So it's mostly like a robot that means for a normal person who is in life, right, he does some mistakes, he gets a punishment for that, he gets something good, he gets positive results from that, and that's how we go through and we try to select based on that experiences that we gain, right, from our mistakes and from the good things that we do, we try to make decisions. So that's what happens in here. So mostly this is like just, okay, so one step it takes and see, okay, something like he takes any of the queen or someone takes a move and he's got checkmate. He understands, okay, that is a wrong step, I should not do. It learns from that, and that's how it goes. So these are the different types of how ML systems are segregated. Now how they're based on learning, so it's something known as a batch and online. So it's offline when the data is too huge, right, and it's not continuous. Something, say price of a house, okay, based on certain criteria, number of rooms, garden, parking lot is there or not. Okay, so those are like, you can train the model after getting all the data, and now you put it into production. Someone comes, it feeds the data and tries to see, okay, what it is predicting. There you don't need to be an online, it's every time it has to gain data or everything. It has nothing like that. Whereas in online, it's like trading, you can say. Every day, different type of news are coming which are impacting the stock price of that, so it has to be like on the go, means, from morning to evening when that stock prices are coming, right, it has to look for news and everything, and it has to predict. So it's like based on online, you can't train it offline and get it here, because every day new news are coming, it has to get trained to better predict the stock prices. Now how they're segregated based on predicting, so it's fairly easy. So it's instance based. So say the example that was, we have different countries whose GDP and how they are happy, this data we have. Okay, so say here the happiness index and here the GDP. Now for a country, you have the GDP but you don't know the happiness index of that. So what you do, you take all the neighboring countries, okay, what is their happiness index, you do an average of them and say, okay, because this is near to this person, it should be like that. So that is instance. Whereas in model, you actually create a model out of it. So uh, uh, usually in this question later you will see, so we will create a linear model where we'll try to predict, okay, if you give this much amount of GDP, we try to predict the output of it. Okay, now so this was usually told in here machine learning, what are the structures that you follow. So first is the data collection part, we try to collect that. Next is the data modeling, where we try to define the problem, what is the data. So data is supervised, unsupervised, evaluation means how much we are going to say it's 95%, our prediction should be 95% correct, and it can keep on changing. What are the different amount of features, those columns that I told you, right? Now what model, machine learning model you are going to use. Okay, for different type of data and everything. You have different types of model, which one is performing good. Then in the experimental you see, okay, this one is not performing good, but I want a better, much better result. Then again you will circle around, try different models, try different features, evaluation you will tweak. So that's how it keeps on going. It circulates and then you finally deploy it. So now the thing comes, that is the main, what are the main challenges of machine learning? Okay, so mostly first is the data. As I told you, right, data is very important. If data is too small, that's an issue. So you can think of it like this. Say you have 10 countries. Okay, so yeah, mostly here, say you have these many countries. Okay, reds are not there, you can think of red data is not there, blue is there. So here you can say, okay, GDP, if the country's GDP is less, its life satisfaction is less. Okay, as we are growing into the GDP, the happiness is also increasing. So this was the prediction. But then this few, the data that we were representing, right, when we plotted that, okay, this graph actually changed. This is now like this. So it's not that there is so much of difference, you can see, right? So it's not that, okay, GDP is increasing, then the happiness is increasing that much. It's by a little margin it is increasing. So see, if you didn't have this data, you would have different means. You have created different meaning out of this only. So that's why the data is very important. It's non-representative. It has to represent all type of countries. So when you try to see, okay, this particular machine, say weighing machine, is helpful or not, you're trying to get data. Now when you get the data, so you send 1,000 people for replies. Okay, so you get from 800 people. Now out of 800 you see 600 are female and 200 are male. Okay, that's not done right. You should have equal proportion of everything, because there can be some amount of bias from male or female. So it, we should have a good representative, it should represent everything. Okay, poor quality data, some of the data which are not important. Okay, or a lot of data is missing, irrelevant feature which are not useful. Okay, so we need to predict that. Sometimes overfitting or underfitting. So this is very important. So what happens, right? First you train the model. Okay, something like, say, as a human week, right, I am preparing for an exam. Okay, so I have been given some 10 chapters. I prepared it so well, I learned everything. Okay, now say you're going for an IIT exam. Okay, which is kind of based on, it's not, it can't be memorized. Yeah, so what you did, you memorized all the questions, all the chapters, all everything. Now it's, now the test that came, right, that was based on understanding, that was not based on memorizing. So that is known as overfitting. So we trained so hard that we memorized all the data. Now when we are giving some questions to it, that guy is not able to answer. So that is overfitting. Now in underfitting, it's, we prepared very less, so we are nowhere ready for the exam. So that is what it is. And so how we split? So the very good example was given in this Udemy course. Okay, so what was that? Say I'm preparing for a board exam. So first 8 months I am learning in the books what are the exercises given, in the end I'm preparing everything. So that is training data. I'm training myself. Okay, now there comes validation. What validation means is, say you learn for 8 months. Now 1 month you are doing sample question papers, if you remember, right, which are kind of our previous year question papers you are trying to solve. So that helps to you to tweak little bit of preparation. Something was missing, you go back again, learn something and come back, so you are better prepared. Now finally the comes, that is the test. That's where the actual answer comes, which you haven't seen before this test data. These you have seen, you have trained, you have learned. So learning phase is still this test. You can't train, you have just to give answer. Okay, so now what are the different stages in data modeling? So first, choosing a data, so that's choosing and training a model. So that's where this trained data comes into the picture. Okay, then comes tuning a model. So this what's come in the validation. You are tuning means just that the last little bit of things that you need to figure out, so that it's okay, you are the better prepared for the example. And then model comparison. So based on different tests, you get different type of score for different model. Which one is good, which one is bad, you predict based on that. So that was it. So that was the full 1 week journey. So it was mostly theory. Okay, but yeah, now with this, from now on we have started with some amount of coding, so that I will cover in the next phase. So thank you. I will put all the links in the description box. Okay, if you feel It's helpful. You should go, if you want to go through, you can go through it. Means these two are where I got, because this is the guy that Daniel Berg I used to follow in YouTube, and I came to know, okay, he has created a course. That's why I got it, and I got it for 450 rupees actually in India. So in Udemy, some days it goes down, then it goes up, so you can keep a track if you want. And this book is also good. So means this I have heard a lot of places that you should start with him, and here mostly I think this guy is the reason why I started, and he actually teaches it pretty well. Means most of the time when I try to teach someone something, right, I assume a lot of things. Okay, he might be doing this, but this guy is like, he starts from scratch everything. He will train it, so yeah, it's good. Okay, so you can follow my notes here. Means it's not something you will learn from it, just so that I keep track of it and make my journey much more interesting. So that's why I'm doing it. So thank you. Thank you.